All right, we're going to review polynomial and rational functions. So the first thing that we have given to us is we have these two polynomial functions, f of x and g of x. So the first thing it wants us to do is find the zeros of f of x. So f of x is that x cubed plus 3x squared minus 6x minus 8. So when I first look at that, I want to try and factor. It's 4 terms, so we try and factor by grouping, but that doesn't work. So then we're going to have to think about those possible rational zeros. And so the possible rational zeros, remember, are from the constant term, those factors. So plus minus 1, plus minus 2, plus minus 4, plus minus 8. And then we're going to divide by the factors of the lead coefficient, which in this case is 1. So really just plus and minus 1. So we have a lot of whole numbers that we could try here. We don't have any fractions. So I'm going to start by just trying a positive 1. So when I try 1, I'm going to do synthetic division. And remember, you take the coefficients of your polynomial. So 1, 3, negative 6, negative 8. And let's see, we'll bring down the 1. Then that multiplies, gets us a 1. 3 plus 1 is 4. We multiply again. That gets us 4. And then we're going to get a negative 2. And that's no way that's going to get an 8. So that didn't work. Okay, so we're going to try something else. How about negative 1? Let's go the negative route instead. 1, 3, negative 6, negative 8. I always like starting with the low numbers and hope I get lucky with that. So we're going to bring down to 1, multiply, that's negative 1, 2, multiply, that's negative 2. Ooh, this is going to work. We get negative 8, then we multiply, that gets 8, so we have 0. So with regards to factoring, I know that if negative 1 is a 0, which we just showed, then x plus 1 is a factor. And then the polynomial left over here is x squared plus 2x minus 8. So again, we're trying to find the zeros. So if we set this equal to 0, we would try and factor that, or use quadratic formula if you like that better. But it's x squared, so that's nice, x and x. And then numbers that will multiply to negative 8 and add to 2, well, that's going to be a 4 and a 2. Keep the 4 positive. And then we still have the x plus 1. And so now that we've factored it into these linear factors, we know the zeros will be a negative 1, negative 4, and a 2. Okay, so those again were the zeros of our f of x. Now, g of x is that x cubed minus 2x squared minus 5x plus 6. That's our g of x function. And so similarly, you could try and factor by grouping, but that's not going to work. So we'll list all the possible rational zeros. And so that comes from the factors of the 6. So plus minus 1, plus minus 2, plus minus 3, plus minus 6, all over the lead coefficient, which is 1. So it's just over 1 and negative 1. Okay, so we're going to test some. Again, I'm just going to start with 1 because that's like easy to start with. And then I'm going to put the lead the coefficients. That will be 1, negative 2, negative 5, 6. So we'll bring down the 1, multiply, we get 1. That's negative 1, negative 1, negative 6, negative 6. Woohoo! That worked perfectly. So then, again, because 1 is a 0, right? We got a 0 remainder. Then x minus 1 is a factor. The polynomial here is x squared minus x minus 6. We're trying to find the 0, so again, we'll try and see if we could factor that guy. And so this factors actually really nicely, x, and then multiplying to negative 6 and adding to negative 1 would be negative 3 and positive 2. So we have x minus 1 times x minus 3 times x plus 2 equal to 0. And so the zeros then, looking at those linear factors, would be a 1, 3, and negative 2. All right, so next one, this is the X-Intercept of the graph of f of x. Really, that's just thinking about the zeros as the points where we cross. So that would be negative 1, 0, negative 4, 0, and 2, 0. You don't do anything else there. We can put commas to separate those 3 things. And then the X-Intercepts for g of x, we'll just look at number 2, and we have 1, 3, and negative 2. So 1, 0, 3, 0, and negative 2, 0. All right, now when we go to number 5, notice that really they've taken those same f of x and g of x and written it as a rational. So if we're asked to find the x-intercepts and the vertical asymptotes, really it's just looking back at that hard work that we just did. So to to find the x-intercepts of a rational function. That's telling us when our function is equal to 0. Well, a fraction is equal to 0 if the numerator is. Okay, so our numerator is really looking at f of x. So we know that f of x, when did that equal 0? It happened at all of those values. And so again, the x-intercepts for this graph will be -1, 0, -4, 0, and 2, 0 by looking at that number 1. For the vertical asymptotes, that's where we're undefined. That's when we have 0 in the denominator. So really that's looking at when our g of x was equal to 0. Now these are vertical asymptotes this time. So if you look at part 5, those were intercepts. Those we're going to list as points. Asymptotes are vertical lines here. So they're going to be x equals. So the first one is going to be, if I go back to where g of x is equal to 0, we're going to get x equals 1. And then we're going to get x is equal to 3 and x equals -2. Those 3 lines are our vertical asymptotes. For number 7, it wants to know if we have a horizontal or a slant. Well, the degrees are the same here. And remember that these asymptotes tell us about the end behavior. So if we look at the biggest degree, that's going to be telling us what's going on in the end. So when x gets really, really big, that stuff doesn't matter, that stuff doesn't matter. We just have x cubed over x cubed, which is really just 1. So those coefficients right there are 1. So since they're the same degree, we'll say y equals that 1 over 1, so 1. So in the end, everything's going to get close to that horizontal line, y equals 1. All right, now we want to determine if our graph crosses this asymptote. And so we're really saying, well, when does x cubed plus 3x squared minus 6x minus 8 over x cubed minus 2x squared minus 5x plus 6, when does that equal that number 1? Does it? Is there any x value that makes that happen? So I'm going to clear the fraction, multiply by the denominator, that mess of stuff here on both sides. So at least we're down to just an equation with a polynomial, not any fractions, so those are gone. So we have x cubed plus 3x squared minus 6x minus 8 is equal to, we'll distribute the 1, which is really just getting us that polynomial. Okay, and so we have this, and so we have x cubes on both sides. I'm going to try and just put everything onto one side. So I'm going to minus x cubed, add the 2x squared, add the 5x, and minus the 6, and do it on both sides. And I'll line them up with their corresponding like term. So on the right side, everything cancels, giving us 0. On the left, the x cubes cancel. X squared, we get 5x squared. Negative 6x plus 5x is a negative x. And then -8 minus 6 is -14. Now, this is down to a quadratic. And so we could try and factor, but actually it doesn't factor. So then we'll have to use the quadratic formula. So x equals -b plus or minus the square root b squared minus 4ac all over 2a. So we have that our a is the 5, our b is -1, and our c is -14. So plugging into that, we're going to get -1 plus minus the square root -1 squared minus 4 times 5 times -14. It's be all over 2 times 5. So we get 1 plus or minus the square root. Well, we'll square the 1 over here, and then we're going to multiply these guys together, which will be a positive 280. So we'll get 281 over 10. Now, if you punch this in your calculator, there's 2 answers. We're going to get x is approximately, well, actually, we can rewrite this first. This is 1 plus the square root of 281, and then divide that by 10, and 1 minus the square root of 281 divided by 10. So when you enter that in your calculator, you're going to get negative about 1.576 and 1.776. So these x values are where we actually cross that asymptote. So hope that was helpful.